The power grid feels miles away when the winter sun drops behind the ridge at 4 in the afternoon. In the dark, a homestead relies on what has been stored up, but chemical batteries fade over time and solar panels do not help when the sky is thick with gray clouds for a week straight. True independence requires something simpler, something mechanical that relies on a constant of the universe. Gravity never drops to zero, and it never sends a monthly utility bill. By hanging a heavy mass from a ceiling joist, a homesteader can trap potential energy and release it slowly to keep a room lit through the night. It is a project built from common scrap metal, some heavy-duty bike chains, and a few discarded gears. It requires no fuel, creates no fumes, and relies entirely on the steady pull of the earth. Imagine a solid white oak timber frame holding a wooden box filled with sand or river rocks. The box weighs exactly 80 pounds. When lifted to the top of a 6-foot frame, that weight holds potential energy just waiting to be converted into usable work. If that weight falls instantly, it creates a loud crash and a second of useless motion. To turn that heavy drop into a slow, steady trickle of electricity, the system needs a gear reduction assembly. This is the mechanical heart of the device, where a fast, heavy force is tamed into a slow, high-torque rotation that can spin a small generator smoothly. The journey of that energy begins at the main drive shaft. A cold-rolled steel rod, 5/8 of an inch thick, sits horizontally across 2 sealed pillow block bearings bolted to the main support beam. Fixed to this shaft is a large bicycle sprocket, boasting 52 teeth, salvaged from an old 10-speed road bike. A heavy-duty roller chain wraps around this sprocket, extending upward toward the ceiling where it connects to the hook on the weighted box. When the box is lifted by hand using a simple ratcheting winch, the chain slips freely over the teeth. When released, the weight pulls down hard, forcing the large 52-tooth sprocket to turn. This first connection is where the magic of mechanical advantage begins to reverse. In a standard machine, gears are used to make a weak force stronger. Here, the goal is to take a massive force and make it last longer. The large drive sprocket is locked to the steel shaft, and right next to it sits a much smaller gear with only 10 teeth. As the large sprocket makes one complete turn, the smaller gear is forced to spin more than 5 times as fast. This initial step-up takes the slow, almost invisible descent of the heavy sandbox and begins to accelerate the movement. From that small 10-tooth gear, a second chain transfers the motion to another large 52-tooth sprocket mounted on a parallel secondary shaft. This secondary shaft is also supported by grease-lubricated ball bearings to minimize friction, because every bit of heat generated by rubbing metal is lost light. This second large sprocket turns at the accelerated speed of the first stage, and it is locked to another small 10-tooth gear on the same axle. By stacking these stages, the rotational speed multiplies exponentially. What started as a slow pull becomes a brisk, steady spin. A third and final stage of gear reduction completes the mechanical chain. The second 10-tooth gear drives a small bicycle hub sprocket attached to the shaft of a permanent magnet direct current motor. This motor, often salvaged from an old treadmill or a broken computer printer, acts in reverse as a high-efficiency generator. Instead of consuming electricity to turn a shaft, the spinning shaft forces the internal copper windings past powerful neodymium magnets, generating a steady stream of direct current electricity. Because the gear ratio is precisely calculated, the 80-pound weight takes exactly 4 hours to travel the 6 feet from the ceiling to the floor. During those 4 hours, the generator spins at roughly 2,000 rotations per minute. The constant, unyielding pull of gravity ensures that the rotation stays perfectly uniform from the moment the weight is released until it touches the ground. There are no spikes in voltage, no flickering, and no sudden drops in current, like those experienced with cheap wind turbines or shaded solar arrays. The wire leading from the generator is a simple 16-gauge copper strand, insulated in thick black rubber to protect it from the damp air of a workshop or cabin. This wire carries the electricity directly to a small, custom-built circuit board mounted on the side of the wooden frame. The core of this board is a simple voltage regulator circuit, designed to smooth out the minor fluctuations that occur as the chain links engage with the sprocket teeth. A small ceramic capacitor stores a tiny charge to bridge the millisecond gaps between gear engagements, ensuring the output remains as steady as a mountain spring. From the circuit board, the smoothed power flows down to a custom-designed light-emitting diode panel. Unlike old incandescent bulbs that waste 95% of their energy as heat, these modern LEDs are incredibly efficient, converting almost every milliwatt of mechanical power into clean, white light. The panel consists of 6 high-efficiency surface-mount diodes soldered onto a small aluminum plate. The aluminum plate acts as a heat sink, drawing away the tiny amount of warmth the LEDs produce and scattering it into the surrounding air to ensure the components last for decades. The light produced by this gravity system is not a blinding floodlight, but a warm, focused glow that easily illuminates a 10 by 12-foot room. It provides enough light to read a map, clean a tool, or prepare a meal on a wood stove without straining the eyes. When the weight finally reaches the bottom of its run, a small mechanical bell tinkers softly, alerting the homesteader that it is time to reset the system. Winding the weight back up takes less than 30 seconds of physical effort using a hand crank, storing another 4 hours of reliable light for the evening ahead. The third critical assembly of this gravity system is the mechanical governor, which acts as the brake to prevent the 80-pound weight from crashing downward all at once. Without this control mechanism, the potential energy would dump in a single, destructive second. To achieve a slow, controlled release, a modified escapement wheel, salvaged from an old grandfather clock or cut from a heavy sheet of 3/16-inch brass, is fixed to the high-speed generator shaft. This wheel features 40 deeply hooked teeth along its outer perimeter. A heavy steel pallet, weighted on one end with a small lead fishing sinker, rocks back and forth on a small pivot pin directly above the wheel. Each time the wheel tries to spin, a tooth catches on one side of the pallet, forcing it to rock backward, which releases that tooth but immediately catches the next one. This rhythmic ticking sound fills the room, a steady acoustic heartbeat that guarantees the energy is being rationed out grain by grain over the 4-hour cycle. To fine-tune the descent speed for different lighting needs, a small air resistance paddle is attached to the very end of the gear train. This paddle consists of 2 flat pieces of galvanized sheet metal, each measuring 3 by 4 inches, bolted to opposite sides of a lightweight aluminum rod. As the high-speed shaft spins, these metal plates cut through the air, create an aerodynamic drag. If the room is cold, the denser air naturally slows the paddle down slightly, lengthening the run time. If more light is needed, the angle of the plates can be twisted using a small pair of pliers, reducing the drag and allowing the generator to spin faster, which increases the voltage output to the LED panel at the cost of a slightly shorter run time. The true synergy of this device is realized when it is integrated into the daily workflow of a self-sufficient homestead. In the late afternoon, as the chores wind down and the livestock are bedded for the night, the physical act of winding up the weight becomes a natural transition into the evening. Pulling the heavy hemp rope attached to the ratcheting winch requires about 40 foot-pounds of human torque, a brief physical exertion that stores enough energy to illuminate the cabin well past midnight. This mechanical storage completely bypasses the vulnerabilities of modern chemical batteries, which degrade rapidly when exposed to the sub-zero winter temperatures common in the high country of Wyoming or the damp, freezing nights of the Midwest. A lead, acid, or lithium battery left in an unheated tool shed will lose its charge or freeze and crack, but a box of river rocks and a set of steel bicycle sprockets function identically whether it is 90 degrees in July or 20 below zero in January. Maintaining the system requires none of the specialized knowledge or proprietary tools demanded by modern electronics. The entire assembly is completely exposed, mounted to a backboard of rough-sawn 3/4-inch exterior plywood that has been sealed with a coat of boiled linseed oil to resist moisture. Every moving part can be inspected at a glance. If a squeak develops, a single drop of standard 30-weight motor oil or a dab of lithium grease applied directly to the chain links with an old toothbrush restores silent operation. The sprockets are secured to the steel shafts using simple hex head set screws, meaning the entire gear train can be torn down, cleaned of dust, and reassembled in less than 20 minutes using a standard set of Allen wrenches. Over time, the components wear together, the rough edges of the stamped metal gears smoothing out through constant contact until the system runs even more efficiently than it did on the day it was built. If a chain link breaks after years of heavy use, it can be replaced using a standard pocket chain breaker tool found in any basic bicycle repair kit, using a spare link salvaged from the same scrap pile that sourced the original parts. This eliminates any reliance on overseas supply chains or specialized replacement parts that could become unavailable during an extended economic disruption. Implementation on the homestead begins with selecting the proper mounting location. The system must be anchored to a structural member capable of supporting not just the dead weight of the 80-pound box, but the dynamic forces exerted when the winch is cranked. A heavy interior partition wall or a main support post next to a wood stove is ideal, as the rising warm air from the stove helps keep the lubricant and grease fluid and reduces mechanical drag. 2 heavy 4-inch lag screws are driven through the plywood backboard directly into the center of a 2x6 wall stud, ensuring the frame remains perfectly plumb. If the frame tilts even slightly, the heavy chains will rub hard against the sides of the sprocket teeth, creating unnecessary friction that drains power away from the light. Once the frame is secure, the electrical line is routed neatly along the baseboards using small insulated staples. The 6-diode LED panel is mounted inside an old tin, which has been polished on the inside with a piece of fine steel wool to act as a highly reflective directional mirror. This simple fixture is hung directly over the kitchen table or the workbench, casting a bright, shadowless cone of light right where the work happens. Because the system operates on a low-voltage direct current, there is absolutely no risk of electrical shock or fire, making it completely safe to run through walls made of rough-sawn lumber, denim insulation, or exposed cordwood. When the grid goes dark during a heavy autumn ice storm, or when the cost of commercial power rises beyond reach, a homestead equipped with gravity lighting remains unaffected. While neighbors scramble for flashlights with corroded alkaline batteries or listen to the loud, thirsty roar of a gasoline generator consuming expensive fuel in the yard, the gravity lamp operates in absolute silence. It represents a return to fundamental mechanics, an acknowledgement that the most reliable systems are those that can be completely understood, maintained, and repaired by the person who relies on them. Sovereignty is not bought from a catalog or delivered by utility wire. It is built piece by piece from the scrap iron, local timber, and physical effort that define a truly independent life.